Hi students, good morning. So in the previous session, we have discussed about the abnormal molar mass, that's the Vanta factor, that is association of solute particles and dissociation of solute particles, and some modified equations by introducing the factor that is called as Vanta factor. So and also there is a relationship between degree of dissociation and the Vanta factor, degree of association and Vanta factors. There is some formula, so we already discussed in the previous session. So and also I discussed about the problems on osmotic pressure. So the continuation part, I think two problems are already clear. So let me take the third problem. At 300 Kelvin, 36 gram of glucose present in a liter of its solution has an osmotic pressure of 4.98 bar. If the osmotic pressure of the solution is 1.52 bar at the same temperature, what would be its concentration at the heading? So very simple problem. So that's the problem number 3 here. So here the temperature is same. So the temperature, there is the same temperature. Same temperature. So 36 gram of glucose present in a liter, and the mass of glucose, that is glucose is acts as a solute here. So 32 gram, so mass of solute, that is 32 gram, and present in a liter of its solution. Liter of its solution is nothing but volume of solution. That volume of solution is equal to 1 liter. That is equal to how much? 1000 ml. So our solution to osmotic pressure, that osmotic pressure is 4.98 bar. That is pi is equal to 4.98 bar. So continuation, if the osmotic pressure of the same solution is 1.52 bar, andre other solution 1.52 bar osmotic pressure adaga ಆಗ concentration ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಹೇಳಿದೆ. ಅಂದ್ರೆ ಸೊ ಇಲ್ಲಿ ಎರಡು ಟರ್ಮ್ ಕೊಟ್ಟಿದ್ದಾನೆ, ಅದರ ಅದೇನ್ ಮಾಡೋಣ, let me take this pi 1. So pi 2 ಅಂತ ಹೇಳಿದ್ದಾರೆ, ಅಂದ್ರೆ pi 2 ಅಂತ ಅಂದಾಗ that is the second osmotic pressure of the same solution. So ಎಷ್ಟಿದೆ 1.52 bar ಅಂತ ಹೇಳಿದೆ, 1.52 bar. ಆ ಟೈಮ್ ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ. So this is very simple. ಅಂದ್ರೆ ಈಗ ನೀವು ಚೆಕ್ ಮಾಡಬೇಕು ಅಂದಾಗ so pi 1 that is 4.98 bar ಇದೆ. So W2 32 gram ಇದೆ, volume of solution 30 ml ಇದೆ. So ಈಗ ನಾವೇನ್ ಮಾಡಬೇಕು, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಯಾವಾಗ pi 2 is equal to 1.52 bar osmotic pressure ಇದ್ದಾಗ concentration of glucose solution ಎಷ್ಟಿರುತ್ತೆ ಅಂತ. So we know the one of the important relationship. That important relation is pi is equal to CRT. Where pi is the osmotic pressure, C is the concentration, nothing but molarity, R is the gas constant and T is the temperature. So already one ಹೇಳಿದಾನೆ temperature is same ಅಂತ ಹೇಳಿದಾನೆ. So ಎರಡು solution the osmotic pressure change ಇದ್ರು temperature same ಅಂತ ಹೇಳಿದಾನೆ, and R value is always constant here. So therefore on this again we can say so pi is proportional to C, where C is the concentration. So concentration nothing but ಯಾವುದು molarity. Concentration is molarity. But ಈಗ ನಾವೇನ್ ಮಾಡಬಹುದು, pi is proportional to C ಅಂದಾಗ so pi 1 is proportional to C1 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ, ಅದು ಫಸ್ಟ್ ಗ್ಲೂಕೋಸ್ ಸೊಲ್ಯೂಷನ್ ಗೆ. ಸೆಕೆಂಡ್ ಅಲ್ಲಿ so pi 2 is proportional to C2 ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಸೊ ಏನ್ ಮಾಡಿ, so 1 and 2 ಅಲ್ಲಿಗೆ pi 1 divided by pi 2 is equal to C1 divided by C2. ಈಗ ನಮಗೆ ಏನಾಗಿದೆ, pi 2 ವ್ಯಾಲ್ಯೂ ಸಿಕ್ಕಿದೆ, ಅಂದ್ರೆ 1.52 ಬರೀತಾಗ so what you have to calculate now, we have to calculate that C2 ಅಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ pi 1 ಕೊಟ್ಟಿದ್ದಾನ, ಸೊ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ 4.98 ಬಾರ್ ಇದೆ. ಸೊ ಆಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಮಗೆ ಗೊತ್ತಿಲ್ಲ, ಸೊ C1 ನ ಫಸ್ಟ್ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. C1 is equal to nothing but molarity of this glucose solution. ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ಇಲ್ಲಿ ಹಿಂಟ್ ಕೊಟ್ಟಿದ್ದಾನೆ ನೋಡಿ, ಮಾಸ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ, that is solute, and volume of solution ಕೊಟ್ಟಿದ್ದಾನೆ. So therefore mass of what is the unit concentration, that is molarity equation, W2 into 1000 whole divided by M2 into V in ml. That is equal to, so W2 is how much, 32 gram or 36 gram, okay 36 gram, sorry 36 gram into 1000 whole divided by, what is the M2? M2 is the molar mass of solute. Molar mass of solute here, M2 is equal to, what is the molar mass of glucose? So glucose formula C6H12O6. So therefore 6 into 12, so 6 carbon atom into atomic mass of carbon plus 12 into atomic mass of hydrogen, that is 1, plus so oxygen 6 into atomic mass is 16, that is equal to 180 gram per mole. So ಅದೆಲ್ಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು ಇವಾಗ ಮಾಡ್ಕೊಳ್ಳಿ, you will get 180 gram per mole is the molar mass of the glucose. That is the solute here. Therefore 180 into volume is how much? That is also 1000 ml. That is 1 liter, 1000 ml. 1000 gets cancelled. That is equal to 36 divided by 180. 36 divided by 180 is nothing but 0.2 molar. That is the concentration C1. So here, so in this concentration, 0.2 molar concentration, nothing but 36 gram of glucose dissolved in 1000 ml of solution. So on that time concentration that is 0.2 molar. That is the concentration C1. So in the concentration C1 ಗೊತ್ತಿದೆ. So ಅದು osmotic pressure ಇಷ್ಟು concentration ಇದ್ದಾಗ osmotic pressure ಎಷ್ಟಿದೆ 4.98 bar ಇದೆ. So ಈಗ ನಮಗೆ pi 2 ಇಷ್ಟಿದೆ ಅಂದಾಗ ಅದರ concentration ಎಷ್ಟು ಅಂತ ಹೇಳಿದಾನೆ. So therefore substitute the value here. So that is pi 1 is equal to 4.98 divided by, so what is the value of pi 2? So pi 2 is equal to 1.5. That is equal to C1 concentration is 0.2 divided by C. Our intention is to calculate the CTD here, nothing but concentration of the solution which is having the osmotic pressure 1.5. So therefore on the solution modify ಮಾಡಿ C2 is equal to ಏನಾಗುತ್ತೆ, so ಇದನ್ನ denominator ಇಂದ numerator ತಗೊಳ್ಳಿ, so ಇದು ಈ ಕಡೆ ಬರುತ್ತೆ, so that is 0.2 into ಏನು ಬರುತ್ತೆ 1.5 whole divided by 4.98. So that is the, so one of the important term, that is 0.2 into 1.5 divided by 4.98. As per the numerator, so that is equal to 0.061 molar. That is the concentration C. So if you margin correct you want to check ಮಾಡಬೇಕು ಅಂದ್ರೆ, so according to this relationship pi is proportional to C, nothing but osmotic pressure is directly proportional to concentration, nothing but molarity. So ಇಲ್ಲಿ, so initially concentration ಎಷ್ಟಿದೆ 0.2 molar ಇದೆ, osmotic pressure is 4.98 ಇದೆ. 4.98 ಇಂದ osmotic pressure ಎಷ್ಟಾಗಿದೆ 1.5 ಅಂತ ಕಡಿಮೆ ಆಗಿದೆ. ಕಡಿಮೆ ಆದ್ಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗಬೇಕು 0.2 ಗಿಂತ ಕಡಿಮೆ ಆಗಬೇಕು. ಸೊ 0.2 ಇದೆ, ಸೊ ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ 0.061 molar ಬರ್ತಿದೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ whose osmotic pressure is 1.5. So that's about the problem number 3. Okay, so let me start the fourth problem. What is the problem here? Determine the amount of calcium chloride. So they are given the I value. Remember, I is very important. Matter factor 2.47 and the dissolved in 2.5 liter of the liter of solution. So it's a 2.5 liter of solution such that its osmotic pressure is 0.75 atmosphere at 27 degrees Celsius. R value 0.0821 liter atmosphere per mole per kg. So here, which is the solute and solvent? So that you have to remember first. So identify the solute and solvent. So in the given problem 4, problem number 4 only, so amount of calcium chloride dissolved in 2.5 liter of solution. So the correction model study method. So liter 2.5 liter of solution such that its osmotic pressure there. Here solute yavu. Solute is calcium chloride, that is CaCl. And also they given the I value. The I is equal to how much? 2.47. That is the Landau factor. Dissolved in 2.5 liter of the solution actually. So therefore volume of solution is equal to 2.5 liter. That is equal to how much? 2500 ml. Remember, 1 liter is equal to 1000 ml. 2.5 liter under 2.5 into 1000 ml. We will get 2500 ml. So its osmotic pressure is 0.7 atmosphere. That is pi is equal to 0.7 atmosphere, and at the temperature how much? That is 27 degrees Celsius. 27 degrees Celsius ಏನು ಮಾಡಬೇಕು? So ಅದನ್ನ ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ by adding 273, that is equal to how much? 300 Kelvin. 273, that is 300 Kelvin. That is the temperature. And also they given the R value. That is R value is equal to 0.0821 liter atmosphere per mole per Kelvin. So now our intention is to calculate. Nodi adu ಏನು ಕೇಳ್ತಿದ್ದಾನೆ, calculate the amount of calcium chloride ಅಂತ ಹೇಳಿದ್ದಾನೆ. In the given problem, calcium chloride is a solute. Amount of calcium chloride is nothing but you have to calculate amount of solute. So therefore amount of solute is nothing but W2 we have to calculate. So W2 ಮಾಡಬೇಕಾದ್ರೆ in the given equation, osmotic pressure equation ಅಲ್ಲಿ we must know the M2 value. What is M2? Molar mass of the solute. Solute is calcium chloride. So find the molar mass of solute. You know the atomic mass of calcium and chlorine. So calcium atomic mass ಅಂದಾಗ, so one calcium ಇದೆ, atomic mass of calcium is 40. Atomic number is 20, atomic mass is 40, and the chlorine is today 2 in it. So atomic mass of chlorine is 35.5. So that is equal to 40 plus 35.5 into 2 is 71. That is equal to 111 gram per mole is the molar mass of calcium chloride. That is the solute here. So now in this problem, they are given the I value. So I value put in the definitely only Vanta factor modified equation. That is modified equations of colligative properties modified by the Vanta factor. So modified equation is so modified equation phi is equal to m just a main equation I value multiply so therefore I into W2 into RT into 1000 whole divided by M2 into V in M. Okay, so that is what you have to calculate. W2 you have to calculate. So equation solve W2 is equal to so in the numerator that is 5 into M2 into V in ml whole divided by I into R into T into 1000. That is the modified equation. So now to find out the W, substitute the values of Y and also M2, V, all the factors. That is Y value is 0.75 into what is M2? So M2 is 111 gram per mole. What is volume? That is 2500 ml whole divided by what is the Van factor? That is 2.47 into R value, that is 0.0821 into temperature is 300 into 1000. So that are the equations. So ಈಗ calculations ಮಾಡ್ಕೊಳ್ಳೋದು. So calculation ಮಾಡ್ಕೊಂಡ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. So ಮೇಲೆ 0.75 into 111 into 2500 is about 228,125. So that is 2,08,125 divided by 2.47 into 0.0821 300 and 1000. So multiply ಮಾಡ್ತಾರೆ we get 60836.19. So that is equal to. So next again multiply divide ಮಾಡ್ಕೊಳ್ಳಿ. So divide ಮಾಡ್ಕೊಂಡಾಗ ನಿಮಗೆ final answer that is 3.421. So here W2 is the mass of solute. Mass is measured in grams. That is the problem number 4. So in the given problem, so there is a new factor, that is I factor is also introduced. Ali I value ಕೊಟ್ಟಿರೋದ್ರಿಂದ so we have to introduce the I value. Modified equation ಅಂದ್ರೆ ಆ equation ಗೆ common equation ಏನಿದೆ pi is equal to W2 RT into 1000 divided by M2 into Vn. This is the common equation for osmotic pressure. But modified equation ಅಂದಾಗ you have to multiply by pi. That is I factor. So that's about the problem number 4. The value is 3.421 gram of calcium chloride that can be dissolved in 2.5 liter of the solution, so that we can get the osmotic pressure 0.75 at a temperature 27 degrees Celsius. So that's about the problem number 4. Let's move on to the problem number 5. Okay, the data. Calculate the osmotic pressure of a solution containing 15 gram of urea in 100 cm cube of its solution at 300 Kelvin. This is a direct problem. So calculate the osmotic pressure. Problem number 5. Calculate the osmotic pressure. So which is the solution? Solute here. Solute is urea. Solute is urea. How much of solute is dissolved? That is W2 is equal to 15 gram of urea. That is dissolved in how much of solution? That is volume of solution is equal to 100 cm. Volume of solution 100 cm3. Of its solution at temperature T is equal to 300 Kelvin, and also they given the R value. So it is R value 0.0821 liter atmosphere per Kelvin per mole per Kelvin. That is the amount of the given data. So now we can calculate the pi. So there is a direct equation. Here there is no Van factor. So therefore, the equation of osmotic pressure is W2 RT into 1000 divided by M2 into V in ml. So all the values are given. That is W2 is given, R is given, and T is given, volume is given, and one more you have to calculate. That is M2. What is M2 here? So M2 is the molar mass of solute. Solute is so urea, NH2, CO, NH2. So calculate ಮಾಡ್ಕೊಳ್ಳಿ. Nitrogen 2 ಇದೆ. So 2 into 14, that is atomic mass of nitrogen. So plus carbon ಮಾಡ್ಕೊಳ್ಳಿ. Carbon 1 ಇದೆ. 1 into 12 atomic mass of carbon. Oxygen 1 ಇದೆ. 1 into 16, that is 16 is atomic mass of oxygen. Hydrogen 4 ಇದೆ. 4 into 1, that is atomic mass of hydrogen is 1. So finally we will get 60 gram per mole. Calculate ಮಾಡ್ಕೊಳ್ಳಿ. 14 2s are 28 plus 12 40. 40 plus 16 is 56. 56 plus 4 is 60. That is M2 is 60 gram per mole. So now substitute the values here. That is equal to, what is the value of W2? That is 15 into R value is 0.0821 into temperature is 300 Kelvin into 1000 whole divided by, what is the value of M2? M2 is 60 gram per mole into volume of solution is 100 cm. That is 100. So when you calculate this, what is the value we will get? So that is in the numerator we will get 369,450. That is the numerator value after multiplication of 15, 0.0821, 300 and 1000, and 16 to 100 is 6000. So that is equal to 369,450 divided by 6000. What do you get? 61.575. That is the pi value. So now what is the unit of pi here? So unit of pi value is 575. R value ennirutte unit. So R value ennirutte unit, that is atmosphere kodidane. So definitely we will get the atmosphere is the unit of the atomic pressure. This problem, that is direct problem. ಇಲ್ಲಿ ಯಾವುದೇ ತರಹದ I value ಕೊಟ್ಟಿಲ್ಲ. So just direct ಆಗಿ ಏನು ಮಾಡಿದಾನೆ, solute ಕೊಟ್ಟಿದಾನೆ, solution volume ಕೊಟ್ಟಿದಾನೆ. So ಒಂದು ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿರೋದು molecular mass of solute you have to calculate first, and then you have to substitute the values, you will get the pi value. That is 61.575 atmosphere is the osmotic pressure of this solution, which is obtained by dissolving 15 gram of urea in 100 cm cube of solution at 300 Kelvin. So that's about the problem number 5. Okay. Question number 6. Problem number 6 is determine the osmotic pressure of a solution prepared by dissolving 25 milligram of potassium sulfate in 2 liter of water at 25 degrees Celsius. Assume that it is completely dissociated. R value is given. So ಇಲ್ಲಿ ಒಂದು term ಕೊಟ್ಟಿದ್ದಾರೆ. So that is completely dissociated ಅಂತ ಹೇಳಿದೆ. ಅಲ್ಲಿ completely dissociated ಆಗಿದೆ ಅಂದ್ರೆ that is 100% dissociation. So already in the previous session I said, so that is when the solute undergo 100% dissociation, Vanta factor is equal to N. So that is one of the important equation I have given already. Degree of dissociation is equal to I minus 1 divided by N minus 1. If the degree of dissociation is 100%, 100% ಆಯಿತು ಅಂದ್ರೆ I is equal to ಏನಾಗಿರುತ್ತೆ? N ಆಗಿರುತ್ತೆ. So ಈಗ ಅದನ್ನ I value ತಗೊಂಡು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಈಗ ನಾವು ಕಂಪ್ಲೀಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಹೇಳ್ತೇನೆ ಅಂದ್ರೆ in this problem I am going to take the I factor also. So now collect the data. What you have to calculate first? Problem number 6. The data, determine the osmotic pressure of solution. 6th problem, determine the osmotic pressure of solution. You have to calculate pi. So a solution prepared by dissolving 25 milligram of potassium sulfate. Here the solute is potassium sulfate, that is K2SO4. That is solute is potassium sulfate. So the potassium sulfate will be K plus, and it's alkali metal having the charge plus here. Sulfate having the charge SO4 minus 2. Therefore the formula is so so therefore the formula become K2SO4. So in 2 liter of water, that is 2 liter of water, nothing but volume, that is equal to 2 liter, that is equal to how much? 2000 ml. At 25 degrees Celsius and 25 milligram of potassium sulfate ಅಂತ ಹೇಳಿದಾನೆ. Solute ಎಷ್ಟಿದೆ? Solute ಯಾವುದು? Potassium sulfate. ಅದರ ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ 25 milligram ಅಂತ ಹೇಳಿದಾನೆ. ಅಂದ್ರೆ W2 is equal to 25 milligram. ಅದು ಸ್ವಲ್ಪ ಗ್ರಾಮೀಕರಣ ಮಾಡ್ಕೊಳ್ಳಿ. So that is 25 into 10 power minus 3 gram. So milligram ಇಂದ ಗ್ರಾಮಿಗೆ ಮಾಡಬೇಕಾದ್ರೆ 10 power minus 3 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. After 25 degrees Celsius, that is T is equal to 25 degrees Celsius, that is equal to 25 plus 273, that is equal to how much? 298 Kelvin. And it is completely dissociated ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಜೊತೆಗೆ R value ಕೊಟ್ಟಿದ್ದಾನೆ. R value is equal to 0.0821 liter atmosphere per Kelvin per not per mole per Kelvin. And completely dissociated andaga again said when the solute undergo complete dissociation. So what is I value is equal to n, that is number of particles after dissociation. So when the potassium sulfate undergo dissociation, so when the potassium sulfate undergo dissociation, that gives two ions, that is two particles, one is K plus and one is SO4 2 minus. So how many K plus ions are obtained? So here the K2SO4 is there. So therefore 2K plus is obtained and SO4 minus 1 ion. Total number of particles is taken, that is 3 ion. So therefore it under complete dissociation is nothing but I value is equal to n, where n is the number of particles obtained after dissociation. So after dissociation, how many particles are obtained? That is 3 particles are obtained. That is I value is equal to 3. So I value again, we are going to use the modified equation. So pi is equal to I into W2 into RT into 1000 divided by M2 into V in Mn. So substitute the value, we will get transfer equation. So what is I value? That is I value is 3. What is W2? That is 25 milligram. 25 into 10 power minus 3. R value is 0.0821 into temperature is 298 Kelvin into 1000. So whole divided by what is M2? So M2 we have to calculate. This is very important. So M2 is the molar mass of solute. What is the solute here? Potassium sulfate. How many potassium atoms? That is 2 into potassium atomic number is 90, atomic mass is 39 plus, so sulfur is there, sulfur 1 is into 32, atomic number is 16, atomic mass is 32 plus oxygen 4 is there into 16 is the atomic mass. So that is equal to so molecular mass na calculate ಮಾಡ್ತಾ ಬನ್ನಿ. M2 is equal to 39 into 2 is 78 plus 32 plus, so 16 4s are 64. That is equal to how much? 174 gram per mole. 174 gram per mole. That is the molar mass of the solute M2. That is M2. Now substitute the value. M2 is equal to 174 into what is the volume? So volume is 2000. So here we will simply calculate it. 10 power minus 3 there. 1000 can be written as 10 power 3. Again 10 power minus 3, 10 power 3 cancel out. So you will multiply. That is 3 into 25 into 0.081 into 298. That is equal to 1834.935 whole divided by 174 into 2000. 174 into 2000, that is 348,000. That is 3,48,000. So we have to multiply. So we will get that 0.00527. That is the value of pi here. So the value overrise scientific notation. So we have 5.27 into. So we will point 10 power minus 3. Then what is the unit of pi here? So R value other put here. So R value is given in atmosphere. So therefore the unit of pi is also in atmosphere. That is atmosphere. So the stick problem with the stop on pi is equal to 0.005% atmosphere ಅಂತ ಬರೆದ್ರು. Okay. So the scientific notation ಬರೆದ್ರೆ 5.27 into 10 power minus 3. So in this problem, so you forgot to include the I factor. I factor ಬಿಟ್ಬಿಡ್ತೀರಾ. ಅವನು ಹೇಳಿದಾನೆ ಹಿಂಗೆ ಕೊಟ್ಟಿದ್ದಾನೆ ಕಂಪ್ಲೀಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಅಂತ ಹೇಳಿದಾನೆ ಅಂತಂದ್ರೆ ಸೊ ಅದು ಅಂಡರ್ಸ್ಟುಡ್ ಐ ವ್ಯಾಲ್ಯೂ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 100% ಕಂಪ್ಲೀಟ್ ಡಿಸೋಸಿಯೇಷನ್ ಅಂತ ನಾನು ಹೇಳಿದ್ದೀನಿ. 100% ಡಿಸೋಸಿಯೇಷನ್ ಆಯ್ತು ಸಲ್ಯೂಟ್ ಅಂದ್ರೆ ಐ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ n ಆಗಿರುತ್ತೆ. When the potassium sulfate undergo dissociation, this is a very good salt actually. So when it is undergo complete dissociation, that gives us 3 ions, 2 K plus ion and 1 sulfate ion. So therefore total number of ions is 3. They are considered as solute particles. Therefore I is taken as 3 here. So after substituting the values of all these factors, we will get the pi value 5.27 into 10 power minus 3 atmosphere. So that's about the problem number 6. Next, problem number 7. Problem number 7. 5% urea solution is isotonic with glucose solution containing 30 gram of glucose in 200 ml solution. Calculate molecular mass of glucose. Here there is one important term, that is isotonic. So in the theory, already I have explained, isotonic solutions are the solutions which are having same osmotic pressure. So if they have the same osmotic pressure, definitely they have the same concentration. So ಇಲ್ಲಿ ನಿಮಗೆ ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ ಯೂರಿಯಾ ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಅಂಡ್ ದೆನ್ ಗ್ಲೂಕೋಸ್ ಸೊಲ್ಯೂಷನ್ ಇದೆ, ಅದರದ್ದು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಎರಡು ಈಕ್ವಲ್ ಬರುತ್ತೆ ಬಿಕಾಸ್ ಆಲ್ರೆಡಿ ದೇ ಸೆಡ್ ದೇರ್ ಇಸ್ ಅ ಐಸೋಟೋನಿಕ್. ಸೊ ಐಸೋಟೋನಿಕ್ ಅಂದ್ರೆ ಎರಡು ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗಿರಬೇಕು, ಸೇಮ್ ಇರಬೇಕು. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದೀನಿ. ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ 100% ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇರುತ್ತೆ. one mark ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ what are isotonic solutions? The solutions which are having the same osmotic pressure, and at the same time for the competitive exams this is very very important. So if the solutions have the same osmotic pressure, definitely those solutions having same concentration. So therefore ಇಲ್ಲಿ ಯಾವ ಯಾವುದು ನಿಮಗೆ isotonic ಆಗಿ ಅಂತ ನೋಡೋಣ. 5% urea solution isotonic with glucose solution ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಗ್ಲೂಕೋಸ್ ಸೊಲ್ಯೂಷನ್. ಸೊ ಈ ಗ್ಲೂಕೋಸ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಗ್ರಾಮ್ ಗ್ಲೂಕೋಸ್ ಎಷ್ಟು ml ಅಲ್ಲಿ ಅಂತ ನೋಡ್ತೀವಿ. ದಟ್ ಈಸ್ ಮಾಸ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ Wg ಅಂತ ತಗೊಂಡು, ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಎರಡು ಸಲ್ಯೂಟ್ ಆಗುತ್ತೆ. ಸೊ ಯಾಕಂದ್ರೆ ಒಂದು ಯೂರಿಯಾ ಸಲ್ಯೂಟ್ ಆಗಿರುತ್ತೆ, ಇನ್ನೊಂದು ಯೂರಿಯಾ ಗ್ಲೂಕೋಸ್ ಇರೋದ್ರಿಂದ Wg ಅಂತ ತಗೊಳ್ಳಿ. ಸೊ Wg ಮಾಸ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ is equal to how much? That is 30 gram. Then volume of glucose solution, that V is equal to volume of glucose solution is 200 ml solution. So what you have to calculate? Molecular mass of glucose you have to calculate. Molecular mass of glucose you have to calculate. So ಈಗ ನಿಮಗೆ W ಗೊತ್ತಿದೆ, ಮಾಸ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ ಗೊತ್ತಿದೆ, ವಾಲ್ಯೂಮ್ ಗೊತ್ತಿದೆ, ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ನ ಈಸಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು. ಜೊತೆಗೆ ಇಲ್ಲಿ ಏನು ಅನ್ಕೊಂಡಿದ್ದಾನೆ 5% ಯೂರಿಯಾ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳಿದ್ದಾನೆ. ಸೊ 5% ಯೂರಿಯಾ ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಯೋದು? ಸೊ ಆಲ್ರೆಡಿ ಸೆಡ್ 5% ಅಂದಾಗ ದಟ್ ಮೇ ಬಿ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಆರ್ ವಾಲ್ಯೂಮ್ ಬೈ ವಾಲ್ಯೂಮ್. ಬಟ್ ಇಲ್ಲಿ ಯಾವ್ದು ತಗೋಬೇಕು ಅನ್ನೋದು ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾಕೆಂದ್ರೆ ಪೈ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಟರ್ಮ್ ಇದೆ. ಸೊ ದಟ್ ಈಸ್ ಅಲ್ಲಿಗೆ ವಾಲ್ಯೂಮ್ ಟರ್ಮ್ ಇದೆ ಅಂದಾಗ ಸೊ 5% is nothing but that is in mass by volume percentage. 5% ಯೂರಿಯಾ ಸೊಲ್ಯೂಷನ್ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್ ಅಂದ್ರೆ ಹೆಂಗ್ ಬರೀತೀರಾ? 5 gram of urea dissolved in 100 ml of solution. That is the meaning of 5% W by the urea solution. So ಇಲ್ಲಿ ನೋಡಿ ಮಾಸ್ ಆಫ್ ಯೂರಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ, WU ಅಂತ ತಗೊಂತೀನಿ. ಮಾಸ್ ಆಫ್ ಯೂರಿಯಾ that is about how much? 5 gram. Volume of urea solution is 100 ml. So under the mass of urea, molecular mass of urea ಗೊತ್ತಿರಲಿ, urea is NH2CO NH2. So in the previous problem ಅನ್ನು ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೆ. NH2CO NH2 ಯೂರಿಯಾಗೆ ಮೋಲಾರ್ ಮಾಸ್ ಎಷ್ಟು ಬರುತ್ತೆ? 60 gram per mole ಬರುತ್ತೆ. So ಈಗ our intention is to calculate the molar mass of glucose. So ಅಂದ್ರೆ ಯಾವ ರೀತಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಆರ್ಎ ಇದೆ. So glucose solution is isotonic with the urea solution. Since they are isotonic, the osmotic pressure of glucose solution is equal to osmotic pressure of urea solution. Osmotic pressure of urea solution. That is glucose solution. That is it. So since they are isotonic, they have the same osmotic pressure. At the same time, isotonic solutions have the same concentration. So therefore, concentration of glucose solution is equal to concentration of urea solution. So what is the concentration? Concentration is nothing but in the osmotic pressure, that is molarity. So molarity formula barkonda idini, that is W2 nothing but glucose mass of solute into 1000 divided by molar mass of glucose into V in ml. Glucose solution, that is equal to concentration of urea solution. So urea solution ತಗೊಂಡಾಗ mass of urea solute, mass of solute ಅಂದ್ರೆ 2 ಅಂತ ತಗೊಂಡ ಬದಲಿಗೆ ಯೂರಿಯಾ ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. So into 1000 whole divided by molar mass of urea into V in ml. What do you have to calculate? You have to calculate molar mass of glucose. That you have to calculate. What is the mass of glucose given? That is 30 into 1000. So 1000 will cancel already. Is a cancel module. So this is 1000 gets cancelled. So 30 divided by molecular mass of glucose or molar mass of glucose we have to calculate into what is glucose solution ಗೆ volume ಎಷ್ಟು ನೋಡ್ಕೊಳ್ಳಿ. Glucose solution ಗೆ volume ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ? That is 200. That is equal to mass of urea. Mass of urea is 5 gram into, so into ilali power cancel agide, so divided by molecular or molar mass of urea, that is 60, into volume of urea solution, that is about 100 ml. So therefore calculation ಮಾಡ್ಕೊಳ್ಳಿ, mg calculate ಮಾಡಬೇಕು. So that mg is equal to ಏನು ಬರೆಯಬಹುದು, ಇದನ್ನ ಈ ಕಡೆ ತಗೊಳ್ಳಿ ನ್ಯೂಮರೇಟರ್ ಗೆ, so 5 ನ ಈ ಕಡೆ ಕಳಿಸಿ ಮತ್ತೆ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಏನು ಸಿಗುತ್ತೆ, so that is 30 into 60 into 100 whole divided by, so ಏನು ಬರುತ್ತೆ 5 into 200. so mg ನ ಕಳಿಸಿದ್ದೀನಿ, 5 ನ ತಗೊಂಡಿದ್ದೀನಿ, so 5 into 2 ಆಯ್ತು 200, 60 into 100 ನ ನ್ಯೂಮರೇಟರ್ ಕಳಿಸಿದ್ದೀನಿ. so ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ, ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ 100 ones 100 twos, so next 2 ones 2 threes ಆಗಿ, sorry 2 threes 6, 30 ಆಗುತ್ತೆ. so next 5 ones 5, 6, so that is equal to 30 into 6, that is 180 gram per mole, that is molar mass of glucose. Yes, of course, glucose molecular formula is C6H12O6. ಅದನ್ನು ಬೇಕಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಡೆಫಿನೆಟ್ಲಿ ಯು ಗೆಟ್ ದ ವ್ಯಾಲ್ಯೂ 180 ಗ್ರಾಮ್ ಪರ್ ಮೋಲ್. ದಿಸ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಏನಪ್ಪ ಅಂದ್ರೆ ಐಸೋಟೋನಿಕ್ ಅಂತ ಕೊಟ್ಟಿದ್ದೇನೆ ಅಂದಾಗ, so definitely they are the same osmotic pressure. At the same time, if the isotonic solutions are the same osmotic pressure, definitely they are the same concentration. ಯಾಕೆಂದ್ರೆ so pi is equal to CRT, so pi is proportional to C. ಅಲ್ಲಿಗೆ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗಬೇಕು, ಸೇಮ್ ಬರಬೇಕು. ಸೊ ದೇರ್ಫೋರ್ ಐಸೋಟೋನಿಕ್ ಸೊಲ್ಯೂಷನ್ ಆರ್ ದ ಸೇಮ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಎರಡು ಸೊಲ್ಯೂಷನ್ ಐಸೋಟೋನಿಕ್ ಪ್ರೆಷರ್ ಈಕ್ವಲ್ ಇದೆ, ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಈಕ್ವಲ್ ಬರುತ್ತೆ. ಅವನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ವಾಟ್ ಯು ಆರ್ ದ ಫ್ಯಾಕ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್, ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಐಡೆಂಟಿಫೈ. ಸೊ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ದಟ್ ಈಸ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆರ್ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಗ್ಲೂಕೋಸ್, ದಟ್ ಈಸ್ 180 ಗ್ರಾಮ್ ಪರ್ ಮೋಲ್. ಸೊ ದಟ್ಸ್ ಅಬೌಟ್ ದ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 7. Okay, on to the next problem. Question number 8. The osmotic pressure of an aqueous solution of sucrose is 4.92 atmosphere at 27 degrees Celsius. What is the molarity of the solution? How many grams of sucrose were dissolved per 250 ml of the solution? And also they given the R value. So R value is given. So first of all, what is the data? So that is question number 8, problem number 8. Problem number 8. Osmotic pressure of aqueous solution of sucrose. So here the solute is sucrose. Solute is sucrose. A sucrose solution osmotic pressure ಕೊಟ್ಟಿದ್ದೇನೆ, that is pi is equal to 4.92 atmosphere. What is the temperature? That is T is equal to 27 degrees Celsius. That is equal to 27 plus 273. That is equal to how much? 300 Kelvin as the temperature. And what is the molarity of the solution? Nothing but concentration C. C is nothing but molarity. Molarity of solution you have to calculate. So at the same time you have to calculate how many grams of sucrose were dissolved per 250 ml of the solution. So sucrose is a solute here. How many grams of sucrose anta helidare? Nothing but mass of sucrose, mass of solute you have to calculate. That is W2 you have to calculate. So that can be dissolved in per 250 ml of the solution. That is volume is given 250 ml of solution. And one more thing, R value is given. R is equal to 0.0821 liter atmosphere per mole per Kelvin. So now our intention is to calculate the two terms here. One is, first you have to calculate concentration molarity. Once you know the molarity, definitely you can calculate the mass of the solute by using the molecular molarity formula. So first step. So what is the relationship between osmotic pressure and concentration? That is pi is equal to CRT, where C is the concentration molarity that we have to find out. Therefore C is equal to pi divided by R into T. What is the pi value? So pi value, that is 4.92 atmosphere divided by R value is given 0.0821 into temperature is 300 Kelvin. that is equal to 4.92 divided by 4.92 divided by 0.081 into 300. So that is about 24.63. So therefore, what is the C here? 4.92 divided by 24.63, that is equal to 0.1997. That is molarity. So here 4.92 atmosphere irutte. Idi R value ನಲ್ಲಿ ಏನಿರುತ್ತೆ ಲೀಟರ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಇರುತ್ತೆ. ಅಟ್ಮಾಸ್ಫಿಯರ್ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ 300 ಇದೆ ಅಂದ್ರೆ ಕೆಲ್ವಿನ್ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಪರ್ ಕೆಲ್ವಿನ್ ಇದೆ, ಕೆಲ್ವಿನ್ ಪರ್ ಕೆಲ್ವಿನ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಇನ್ನು ಉಳ್ಕೊಳ್ಳೋದು ಸೊ ಲೀಟರ್ ಪರ್ ಮೋಲ್. ಸೊ ಎಲ್ಲರೂ ಕೂಡ ಇದು ಕೆಳಗಡೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಲೀಟರ್ ಪರ್ ಮೋಲ್ ಡಿನಾಮಿನೇಟರ್ ಇರುತ್ತೆ, ಅದು ಮೇಲೆ ಬಂದಾಗ ಏನಾಗುತ್ತೆ ಮೋಲ್ ಪರ್ ಲೀಟರ್. ಸೊ ರಿಮೆಂಬರ್ ಮೋಲ್ ಪರ್ ಲೀಟರ್ ಇಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮೊಲಾರಿಟಿ. So repeat once again, 4.92 atmosphere. So atmosphere is there 0.0821 liter atmosphere per mole per milli. So atmosphere cancel ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಟೆಂಪರೇಚರ್ 300 ಕೆಲ್ವಿನ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಪರ್ ಕೆಲ್ವಿನ್ ಇದೆ. ಸೊ ಪರ್ ಕೆಲ್ವಿನ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಇನ್ನ ಡಿನಾಮಿನೇಟರ್ ಉಳಿಯೋದು ಲೀಟರ್ ಮತ್ತೆ ಪರ್ ಮೋಲ್. ಪರ್ ಮೋಲ್ ಮೇಲೆ ಬಂದ್ರೆ ಮೋಲ್ ಆಗುತ್ತೆ, ಲೀಟರ್ ಮೇಲೆ ಬಂದ್ರೆ per liter ಆಗುತ್ತೆ. So that is equal to 4 mole per liter, simply 0.197 capital M. That is the concentration, molarity. So once you know the molarity, so you can easily calculate the mass of the solid. What is the molarity equation? So molarity concentration C is equal to W2 into 1000 divided by M2 into V in ml. So what you have to calculate? W2 mass of sucrose you have to calculate. That is the mass of solute. W2 is equal to same but W2 like the concentration C molarity into M2 into V in ml divided by 1000. So in concentration go there. So W2 is equal to what is the concentration? That is 0.1997 into. So what is M2? M2 ಗೊತ್ತಿಲ್ಲ. M2 is the molar mass of the solute. Solute ಯಾವುದು? Sucrose. So therefore molar mass of solute you have to calculate. Sucrose ಅನ್ನೋದು disaccharide, that is having the formula C12H22O11. Then calculate ಮಾಡ್ಕೊಳ್ಳಿ. Carbon 12 ಇದೆ into atomic mass is 12 plus hydrogen 22 ಇದೆ, atomic mass is 1 plus oxygen 11 ಇದೆ, atomic mass is 16. Okay, so that is equal to, that is 12 into 12, that is 144 on the birthday. So again, so that is 22 into 1, that is 22 plus 11 into 16, that is 176. So when I add this 144 plus 22 plus 176, we will get 342 gram per mole. That is the molar mass of sucrose. That is C6, C12, H22, O11. Substitute the value, that is 342 into volume is given. So volume how much? That is 250 ml. So that is 250 whole divided by, so that is 1000. That is equal to 0.1997 into 342 into 250. So that is about 17,074.35 whole divided by 1000. That is equal to how much? 17.074. That is W2. What is W2? That is the mass of solute. So mass is nothing but measured in grams. That is the 17.074 gram of sucrose that can be dissolved per 250 ml of the solution. So to get the concentration, that is 0.1997. So ಇಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂತ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಸೊ ಪೈ ವ್ಯಾಲ್ಯೂ ಟೆಂಪರೇಚರ್ ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾನೆ. ಫಸ್ಟ್ ಮೊಲಾರಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಒನ್ಸ್ ಯು ನೋ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಯು ಕ್ಯಾನ್ ಈಸಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಮಾಸ್ ಆಫ್ ಸಲ್ಯೂಟ್. ದಟ್ ಈಸ್ W2 we have to calculate. So 2 is nothing but solute, solute is here sucrose. So sucrose ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ M2 ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. M2 is C12H22O11 is the molecular formula of the sucrose, that's a disaccharide. So M2 is equal to calculate multiply, you will get 342 gram per mole. So put the value, you will get the W2, that is the mass of sucrose, mass of solute. That's about the 17.074 gram of sucrose is of value. That's about the problem number 8. Next, problem number 9. Calculate the osmotic pressure of 5% urea solution at 300 Kelvin. This is also direct problem. So R value is given 0.0821 liter atmosphere per mole per Kelvin. 5% urea solution. So you osmotic pressure calculations only percentage ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾನೆ ಸೊಲ್ಯೂಷನ್ ಅಂತಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಈಸ್ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್. ಇನ್ ಕೇಸ್ ಅವ್ರು ಏನಾದರೂ ಬೇರೆ ಕೊಡಬೇಕು ಅಂದಾಗ ಸೊ ದೇ ವಿಲ್ ಮೆನ್ಷನ್ ಇನ್ ದ ಬ್ರಾಕೆಟ್. ಸೊ ಅದನ್ನ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ತಾರೆ, ಬಟ್ ಇಲ್ಲಿ ಅವ್ರು ಏನು ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ ಸೊ 5% ಯೂರಿಯಾ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಅಂಡರ್ಸ್ಟುಡ್. ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಟರ್ಮ್ ಬರೋದ್ರಿಂದ ಡೆಫಿನೆಟ್ಲಿ ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಕೊಟ್ಟರೆ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅದರ ಮೀನಿಂಗ್ ಬರೋಣ. ಸೊ ವಾಟ್ ಈಸ್ ದ problem, given problem, that is problem number 9. We have to calculate osmotic pressure of 5% urea solution. 5% urea solution. What is the meaning of 5% urea solution? That is 5 gram urea dissolved in 100 ml of solution. 100 ml of solution. Andre 5 gram urea in 100 ml of solution andre mass by volume percentage. What is the temperature is given? Temperature is equal to 300 Kelvin. And what is R value? R value is equal to 0.0821 liter atmosphere per Kelvin per. So one more you have to calculate to calculate the osmotic pressure, that is M2. Which is the solute here? Solute is urea. Solute is urea. What is the formula of urea? So NH2 CONH2. This is the urea formula, molecular formula. So now the previous problem already calculate made the urea do. So that is M2 is equal to 60 gram per mole. So we calculate ಮಾಡ್ಕೊಳ್ಳಿ 60 gram per mole. So now that formula Y is equal to W2 into R into T into 1000 divided by M2 into V in M. Now that is W is equal to mass of solute. Which is the solute here? Urea. What is the mass of solute? That is W2 is equal to 5 gram. So this is the volume of solution. That is V is equal to 100 ml. So that is mass of solute is 5 gram. R value 0.0821 into temperature is 300 Kelvin into 1000 whole divided by what is M2? Molar mass of solute. Solute molar mass is 60 gram per mole and volume of the solution is 100. That is equal to numerator calculate ಮಾಡ್ಕೊಳ್ಳಿ 5 into 0.0821 into 300 into 1000. That is about 123150. That is 1,23,150 divided by 60 into 100 is 6,000. That is equal to what is the value of Y now? So that is 20.525. What is the unit? Unit of osmotic pressure is mainly depends on the R value. So what is R value here? 0.081 liter atmosphere. So therefore the unit of osmotic pressure here is atmosphere. That is the question number 9. So here, so in the question number 9, so percentage ಕೊಟ್ಟಿದ್ದಾನೆ osmotic pressure calculations ಅಲ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. So in case percentage ಅಲ್ಲಿ ಏನಾದರೂ ಸಲ್ಯೂಟ್ ಕೊಟ್ಟಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಅದು ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್ ಆಗಿರುತ್ತೆ. ಯಾಕಂದ್ರೆ osmotic pressure calculations ಅಲ್ಲಿ there is a volume term. So mass by volume percentage ಆಗಿರುತ್ತೆ. So 5%. ಅದಕ್ಕೆ ನಾನು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ಹೇಳಿದ್ದೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್ ಅಲ್ಲಿ ಪರ್ಸೆಂಟೇಜ್ W by W, W by V, V by V ಅಂತ ಕೊಟ್ಟಾಗ ಅದನ್ನ ಬರ್ಕೋಣ ಕರೆಕ್ಟ್ ಆಗಿ ಬರಬೇಕು. 5% urea solution in the osmotic pressure problem definitely there is a mass by volume. So mass by volume ಅಂದಾಗ ಸಲ್ಯೂಟ್ ಮಾಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, solution the volume ಅಲ್ಲಿ ಇದೆ. That is 5 gram urea in 100 ml. Percentage is nothing but 100 ml. So 100 ml of solution. So after getting the data, so after calculating the pi, we'll get 20.525 atmosphere in the problem number 5. So that's about the problem number 5. I think so that's about the problems on osmotic pressure. So in the remaining ಅದೇ ಒಂದು ಸ್ಟಾರ್ಟಿಂಗ್ 9 ಆದಮೇಲೆ ವರ್ಕೌಟ್ ಅಂತ ಹೇಳಿ ಕೆಲವೊಂದು 4-5 ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅನ್ಕೊಂತೀನಿ osmotic pressure ಸ್ಟಡಿ ಮೆಥಡ್ ಅಲ್ಲಿ. ಸೊ ಆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸೇಮ್ ಇದೇ ತರನೇ ಬರುತ್ತೆ. ಸೊ ಅದು ಬೇರೆ ತರ ಏನು ಡಿಫರೆನ್ಸ್ ಇರೋದಿಲ್ಲ, ಸೇಮ್ ಇದೇ ತರ ನೀವೇನು ಫಾರ್ಮ್ ಆಫ್ ಬ್ಯಾಂಡ್ ಫ್ಯಾಕ್ಟರ್ ಕೊಟ್ಟಿದ್ದಾರಾ ಇಲ್ವಾ ಅದನ್ನ ನೋಡ್ಕೊಂಡು ನೀವು ಇನ್ನು ಮಿಕ್ಕಿದ ಪ್ರಾಬ್ಲಮ್ ವರ್ಕೌಟ್ ಅಂತ ಏನು ಕೊಟ್ಟಿದ್ದೀನಿ ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ನೌ ಐ ಮೂವ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, ದಟ್ ಈಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ಎಲಿವೇಶನ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ and depression of freezing point. So before that you have to remember the formulas. Delta TB, that is elevation of boiling point, is equal to Kb into molality. So molality is nothing but number of moles of solute dissolved in 1 kg of solvent. Molality is equal to W2 into 1000 divided by M2 into W1 in grams. ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. and delta TB ಬಗ್ಗೆ ಗೊತ್ತಿರಲಿ, delta TB is equal to TB minus T0P, where TB is the boiling point of solution T naught B is the boiling point of pure solvent. At the same time, delta TF is equal to KF into M, that is small m, that is molarity. Again, M value substitute ಮಾಡ್ಕೊಳ್ಳಿ, molarity formula ಗೊತ್ತಿರುತ್ತೆ. So delta TF is equal to T naught F minus TF, where T naught F is the freezing point of pure solvent and TF is the freezing point of solution, and delta TF is the depression of freezing point. At the same time, KF is the cryoscopic constant ಅಥವಾ molar depression constant ಅಥವಾ so and the molar depression constant or cryoscopic constant, and also freezing point depression constant ಅಂತ ಹೇಳ್ತೀವಿ. And Kb is the molar elevation constant or ebullioscopic constant ಅಂತ ಕರೀತೀವಿ, ಅಥವಾ ಅದನ್ನ so molar elevation constant ಅಂತಲೂ ಕರೀತೀವಿ. So that's about the problems, so that's about the formulas on the elevation of boiling point and depression of freezing point. So let me start the problem. ಅದೇ ಪೇಜ್ ಅಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಕೊಳ್ಳಿ. So page number elevation of boiling point and freezing point 44 page number study meter page number 44 45 ಅಲ್ಲಿ problems ಬರುತ್ತೆ. So let me start the first problem on elevation of boiling point and depression of freezing point. A very important problems in the first problem, page number 44 ಅಲ್ಲಿ ಇದೆ ನೋಡಿ, ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಪೇಜ್ ಅಲ್ಲಿ. ಸೊ ಅದಾದ್ಮೇಲೆ 45 ಅಲ್ಲಿ ಮಿಕ್ಕಿದ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರುತ್ತೆ, ಅದರಲ್ಲೂ ಸಹ ವರ್ಕೌಟ್ ಅಂತ ಇದೆ. ಸೊ ಐ ವಿಲ್ ಸಾಲ್ವ್ ದ 10 ಕ್ವೆಶ್ಚನ್ಸ್. ಐ ಥಿಂಕ್ 10 ಕ್ವೆಶ್ಚನ್ಸ್ ಇರಬೇಕು. ಐ ವಿಲ್ ಡೂ ದ 10 ಕ್ವೆಶ್ಚನ್ಸ್ ಅಂಡ್ ರಿಮೈನಿಂಗ್ ನೀವು ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್, 18 ಗ್ರಾಮ್ ಆಫ್ ಗ್ಲೂಕೋಸ್ dissolved in 1 kg of water ಅಂತ ಹೇಳಿದೆ. So which is a solute. First we have to identify the solute and solvent. In the first problem, glucose solute as glucose, and which is solvent here, that is solvent is water. So glucose ready 18 gram of glucose ಅಂತ ಹೇಳಿದ್ರೆ, that is mass of solute, that is W2 is equal to 18 gram. Dissolved in 1 kg of water ಅಂತ ಹೇಳಿದ್ರೆ, water is a solvent here, that is mass of solvent, one referred for solvent, and 1 kg. 1 kg is nothing but 1000 gram. At what temperature will water boil? At 1.013 bar, and also Kb is given. Kb is constant for a given solvent. In the given problem, the solvent is water. What is the Kb value? That is molar elevation constant or ebullioscopic constant. That is about 0.52 Kelvin kg per mole. So our intention is what you have to calculate here. At what temperature will water boil ಅಂತ ಹೇಳಿದ್ರು. at 1.013 bar ಅಂತ ಹೇಳಿದ್ರೆ, ಅಂದ್ರೆ ಏನ್ ಮಾಡಿದಾನೆ, ಗ್ಲೂಕೋಸ್ ಅನ್ನ 1 kg ಆಫ್ ವಾಟರ್ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾನೆ. ಆಗ ನಿಮಗೆ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ವಾಟರ್ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ ಅಂತ. ಗ್ಲೂಕೋಸ್ ಅನ್ನ ವಾಟರ್ ಹಾಕಿದಾನೆ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಬಿಕಮ್ ಎ ಸೊಲ್ಯೂಷನ್. ಅಂದ್ರೆ ಆ ಸೊಲ್ಯೂಷನ್ ಏನಿದೆ, ಈಗ ಗ್ಲೂಕೋಸ್ ಇದೆ ಜೊತೆಗೆ ವಾಟರ್ ಇದೆ. ಆ ಗ್ಲೂಕೋಸ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ವಾಟರ್ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ. ಸೊ ದಟ್ ಈಸ್ ಅವರ್ ಇಂಟೆನ್ಷನ್ ಇಸ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್. That is TB. TB is the boiling point of solution. Then what is T naught B? So T naught B is to surrender. So T naught B is the boiling point of pure solvent. So pure solvent boiling point ಕೊಟ್ಟಿಲ್ವಲ್ಲ ಅಂತಂದ್ರೆ ಒಂದು ಹಿಂಟ್ ಕೊಟ್ಟಿದ್ದಾನೆ. Boil at 1.013 bar ಅಂತ ಹೇಳಿದ್ದಾರೆ. 1.013 bar is nothing but 1 atmosphere. So it is the boiling point of solvent or boiling point of liquid. It is the temperature at which vapor pressure is equal to 1 atmospheric pressure. 1 atmospheric pressure is nothing but 1.013 bar. And 1.013 bar ಅಲ್ಲಿ ನಾವು boiling point boil ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ವಾಟರ್. So what is that boiling point of the water? That is 100 degrees Celsius. So ಅದು ಪ್ಯೂರ್ ವಾಟರ್ ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. So 1.013 bar vapor pressure is equal ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಅದು boiling point ಆಗಿರುತ್ತೆ. The boiling point of the pure water is 100 degrees Celsius. ಅದನ್ನ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಬರ್ಕೋಬಹುದು. ಹೆಂಗ್ ಬರ್ಕೊಂತೀರಾ? 100 degrees Celsius plus it's a very important elevation of boiling point and depression of freezing point problems ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ, ಸೊ ನೀವು ಟೆಂಪರೇಚರ್ ನ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇಂದ ಕೆಲ್ವಿನ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ 273.15 ನ ಆಡ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂದ್ರೆ ನಾವು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಟೆಂಪರೇಚರ್ಗೆ ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ 273 ಅಂತ ಆಡ್ ಮಾಡ್ಕೊಂತೀವಿ. ಬಟ್ ಇದರಲ್ಲಿ ವೆರಿ ಪಾಯಿಂಟ್ 1 ಸಹ ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ. ಸೊ ಅದರಿಂದ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂನ ಆಡ್ ಮಾಡ್ಕೋಬೇಕು 273.15. This is the exact value used to convert the degree Celsius into Kelvin. So as per there, that is 373.15 Kelvin per there. So T naught B, that is the vapor pressure of pure solvent, that is pure water, in degree Celsius rather than degree Celsius, Kelvin rather. It's a very important. Please remember this 273.15. So that is 373.15 Kelvin. Especially it is used for e problems. Elevation of boiling point and depression of freezing point. So in we calculate TV. What is the equation for elevation of boiling point? That is delta TB is equal to Kb into W2 into 1000 whole divided by M2 into W1 in grams. So first thing delta TB karna, that is equal to, what is the value of Kb? So Kb is equal to 0.5 in. What is W2? That is 80 into 1000 whole divided by, what is M2? So M2 you calculate. So M2 is equal to molecular or molar mass of solute. Which is a solute here? Solute is the glucose. Glucose formula C6H12O6. So already in the previous formula calculate. So that is about 180 gram per mole is the molar mass of glucose. So therefore molar mass of glucose is 180 into W1 is the mass of solvent. What is the mass of solvent here? 1 kg. 1 kg is nothing but 1000 gram. Like the mass of solvent in grams so 1000 gram. So 1000 cancel agutte. So again 18 ones are 18 tens are over there. 0.52 divided by 10 is equal to 0.052. That is delta T variant. So here there is a one confusion problem. So this is a difference between the boiling point of the solution and boiling point of the solvent. This is the elevation of boiling point. And then solvent test itu. So glucose add ಮಾಡಿದಾಗ solution ಆದಾಗ boiling point rise ಆಗುತ್ತೆ. ಎಷ್ಟು rise ಆಗಿದೆ? 0.05 ಇದೆ. ಈಗ ಇದು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಬರಿಬೇಕಾ ಅಥವಾ ಕೆಲ್ವಿನ್ ಬರಬೇಕಾ? This is very important. Since it is a difference, delta TB ಇರೋದು ಡಿಫರೆನ್ಸ್ ಆಗಿರೋದ್ರಿಂದ, ಅಂದ್ರೆ TB ಮೈನಸ್ T ನಾಟ್ ಬಿ ಆಗಿರೋದ್ರಿಂದ ಆ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ನೀವು ಕೆಲ್ವಿನ್ ಅಲ್ಲಾದ್ರೂ ತಗೋಬಹುದು ಅಥವಾ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಾದ್ರೂ ತಗೋಬಹುದು. ಸೊ ನಾನು ಎರಡಕ್ಕೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ. ಲೆಟ್ ಮಿ ಟೇಕ್ ದಿಸ್ ಇಸ್ ದ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ 0.052 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಆಗಿದೆ. ಈಗ ನಮಗೆ ಡೆಲ್ಟಾ TB ಎಲ್ಲ ಬೇಕಾಗಿದೆ. ನಾವು ರಿಲೇಷನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ TB. ವಾಟ್ ಇಸ್ ಡೆಲ್ಟಾ TB? TB minus T naught. That is equal to 0.052 degree Celsius. ಇಲ್ಲಿ ನಮಗೆ TB ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. That is equal to 0.052 degree Celsius plus minus delta T naught B naught ಕಳಿಸಿ plus T naught B ಆಗುತ್ತೆ. That is equal to 0.052 degree Celsius plus. ಈಗ T naught B ನ ಏನು ತಗೋಬೇಕು? ಸೊ T naught B ನ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ತಗೋಬೇಕಾ ಅಥವಾ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ತಗೋಬೇಕಾ? ಇಲ್ಲಿ ನೀವು ಡಿಫರೆನ್ಸ್ ಅನ್ನ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ತಗೊಂಡಿರೋದ್ರಿಂದ T naught B ಅನ್ನು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ತಗೋಬೇಕಾಗುತ್ತೆ. So that is 100 degree Celsius. That is equal to how much? 100.052 degree Celsius is the boiling point of solution. So correct again we check ಮಾಡ್ಕೊಳ್ಳೋದು. So what is the pure solvent boiling point? That is 100 degree Celsius. When you add the solute into the solution solvent, it becomes a solution. What happens to the boiling point? It gets elevated. That's why it is called as the elevation of boiling point. ಎಷ್ಟು ಎಲಿವೇಟ್ ಆಗಿದೆ? 0.052 still there. And the solution boiling point ಎಷ್ಟಾಗುತ್ತೆ? 100.052. This is higher than that of the T naught B. Always boiling point of solution is higher than of the boiling point of pure solvent. ಇದು ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಗೋ. ಇದು ಕರೆಕ್ಟ್ ಇದೆ. So sometimes ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗಿ ಸರ್ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ತಗೊಂತೀನಿ ಅಂತಿದ್ರೆ, if you take delta TB is equal to 0.052 Kelvin ಅಂತ ತಗೊಂಡ್ರೆ same calculation, that is TB minus T naught B is equal to 0.052 Kelvin. So what is TB? So TB you have to calculate, that is equal to 0.052 Kelvin. So ಈ ಕಡೆ ಏನಾಗುತ್ತೆ plus T naught B. That is equal to 0.052 Kelvin plus ಈಗ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ T naught B ನ ಯಾರು ತಗೋಬೇಕು? That should be Kelvin here. So 373.15 Kelvin ತಗೋಬೇಕಾಗುತ್ತೆ. That is 373.15 Kelvin. So ಇದನ್ನ ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. So that is TB is equal to how much you get? 373.202 Kelvin. That is TB then. ಸರಿ, ಇವೆರಡು ಕರೆಕ್ಟ್ ಆಗ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಗೊಂಡಾಗ ಇದು ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಸೊ ಅದೇ ನೀವು ಕೆಲ್ವಿನ್ ತಗೊಂಡಾಗ ಇದು ಕರೆಕ್ಟ್ ಆಗಿದೆ. ಸೊ ಈಗ ನಿಮಗೆ ಇವೆರಡು ಸೇಮ್ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೀವು ಈ ತರ ಮಾಡ್ಬೋದು, ಈ ತರ ಮಾಡೋದು ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ, ಈ ತರ ಮಾಡೋದು ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ನಿಮಗೆ ಡೌಟ್ ಬಂದ್ರೆ ಇಲ್ಲಿ 100.052 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದೆ, ಅದನ್ನ ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡಿ. ಅಂದ್ರೆ ಬೈ ಆಡಿಂಗ್ 273.15 ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ವಿಲ್ ಗೆಟ್ 373.202. ಇದಕ್ಕೆ ನೀವು ಏನು ಮಾಡ್ಕೊಳ್ಳಬೇಕಾದ್ರೆ 100.052 ಪ್ಲಸ್ 273.15 ಸೊ ಅಂದರೆ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ನ ಕೆಲ್ವಿನ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇದನ್ನ ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಸೊ ವಿಲ್ ಗೆಟ್ ದ ವ್ಯಾಲ್ಯೂ. ಸೊ ಅಂದ್ರೆ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ನೀವೇನ್ ತಗೋಬಹುದು, ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ನಾರು ತಗೊಳ್ಳಿ ಇಲ್ಲ ಕೆಲ್ವಿನ್ ನಾರು ತಗೊಳ್ಳಿ. ಸೊ ಆಫ್ಟರ್ ಕೆಲ್ವಿನ್ ಆ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಗೊಂಡ ಮೇಲೆ ನೀವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಕ್ಕಂಥ T0B ಅನ್ನ ಡಿಫರೆನ್ಸ್ ಏನ್ ತಗೊಂಡಿರ್ತೀರ, ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ತಗೊಂಡಿದ್ರೆ T0B ಅಥವಾ TB ಅನ್ನ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲೇ ತಗೋಬೇಕಾಗುತ್ತೆ. ಸೊ ಇನ್ ಕೇಸ್ ನೀವು ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ತಗೊಂಡ್ರೆ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ಡೆಲ್ಟಾ TB ಅನ್ನ ಅಂತಂದಾಗ ಸೊ T0B ಅಥವಾ TB ವ್ಯಾಲ್ಯೂ ಅನ್ನ ಕೆಲ್ವಿನ್ ಅಲ್ಲೇ ತಗೋಬೇಕು, ಫೈನಲ್ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಎರಡಕ್ಕೂ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ. ಸೊ ನೀವು ಯಾವ ತಗೊಂಡ್ರು ಅದ್ರ ಬೆಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಇನ್ ಕೇಸ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ತಗೊಂಡಿರ್ತೀರಾ ಮತ್ತೆ 373.15 ಅಂತ ಆಡ್ ಮಾಡಿಲ್ಲ ತಪ್ಪಾಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದೆ ಕೆಲ್ವಿನ್ ಬರುತ್ತೆ. ಸೊ ಮತ್ತೆ ಇಲ್ಲಿ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಇದ್ರೆ ಅಗೇನ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್, ಕೆಲ್ವಿನ್ ಅಂತ ತಗೊಂಡ್ರೆ ಕೆಲ್ವಿನ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಯಾವ್ದನ್ನ ಓನ್ಲಿ ಡಿಫರೆನ್ಸ್ ನ ಮಾತ್ರ, ಡಿಫರೆನ್ಸ್ ಯಾವ್ದನ್ನ ತಗೊಂಡ್ರು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದನ್ನೇ ಮಾಡಬೇಕಾಗುತ್ತೆ. Those are the question number 1, that is about the value 373.202 Kelvin. So that's about the problem number 1, that is 18 gram of glucose dissolved in 1 kg of water. So dissolve ಮಾಡಿದಾಗ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಆ ವಾಟರ್ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ, that is 373.202 Kelvin or 100.052 degree Celsius. So that's about the problem number 1. Let's move on to the second problem. So boiling point of benzene is 352.23 Kelvin. When 1.8 gram of non-volatile electrolyte solute was dissolved in 90 gram of benzene, the boiling point is raised to 354.11 Kelvin. Calculate the molar mass of solute and Kb is given. This is a direct problem. So collect the data. So first identify which is the solvent and which is the solute here. So in the second problem, the boiling point of benzene is under ಕೊಟ್ಟಿದ್ದಾನೆ. So benzene ಮಾತ್ರ ಕೊಟ್ಟಿದ್ದಾನೆ, ಇಲ್ಲಿ solute ಏನಂದ್ರೆ non volatile electrolyte solute ಅಂತ ಹೇಳಿದ್ದಾನೆ. So 100% ಅಂದ್ರೆ solvent is benzene. Solvent is benzene. So ಅಂದ್ರೆ benzene ದು boiling point ಕೊಟ್ಟಿದ್ದಾನೆ. So benzene solvent ಅಂದ್ರೆ that is pure solvent ಆಗುತ್ತೆ, that is T0B is equal to 352.23 Kelvin. When 1.8 gram of the non-volatile electrolytes, that is mass of solute is equal to 1.8 gram. Electrolyte solute was dissolved in 90 gram of benzene. Here the benzene is a solvent. 90 gram of benzene nothing but mass of solvent, that is W1 is equal to 90 gram. The boiling point raised. So already we said in the elevation of boiling point, when the solute is added to the solvent, definitely the boiling point is elevated. So how much is elevated? That is 354.11 Kelvin. Yesterday 352.23 ಇದೆ pure benzene ದು. Solute ಅನ್ನು 1.8 gram ಅಷ್ಟು ಆಡ್ ಮಾಡಿದಾಗ 90 gram of benzene ಗೆ, so the boiling point of solution ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ solute is added to solvent, it become a solution. That solution having the boiling point, that is TB, boiling point of solution 354.11 Kelvin. So our intention is to calculate the molar mass of solute, that is M2 we have to calculate, and also they given the Kb absorptive constant of our benzene, that is 2.53 Kelvin kg per mole. So here there is a direct formula, delta TB is equal to Kb into W2 into 1000 divided by M2 into W1 in grams. So all the data are given already. So what is Kb value? Kb is equal to 2.53 into W2 is 1.8 into 1000 whole divided by molar mass of solute, that we have to calculate into W1 is 90 gram, delta TB. So delta TB is nothing but TB minus T0. So in electrical calculate ಮಾಡ್ಕೊಳ್ಳಿ, in assignment calculate ಮಾಡಬಹುದು. So TB value is given. So TB value is 354.11 Kelvin minus what is T0B? That is 352.23 Kelvin. That is equal to 2.53 into 1.8 into 1000 whole divided by M2 into 9. So the difference is 354.11 minus 352.23. So that is about 1.88. 1.88 is equal to 2.53 into 1.8 into 1000 whole divided by m2 into 90. So therefore m2 we have to calculate. So class multiply ಮಾಡ್ಕೊಳ್ಳಿ, m2 numerator ತಗೊಂಬನ್ನಿ, 1.8 denominator ಹೋಗ್ಲಿ. So ಏನು ಬರುತ್ತೆ 2.53 into 1.8 into 1000 whole divided by 1.88 into 90. So numerator calculate ಮಾಡ್ಕೊಳ್ಳಿ. So numerator value you get, that is 4554 divided by 1.88 into 90, that is 169.2. So therefore m2 is equal to 4554 divided by 169.2, that is about 26.914. That is the molar mass of solute here. So molar mass of solute, what's the unit? That is gram per mole. So here this is a direct formula, 3 marks question. So direct formula use ಮಾಡ್ಕೊಳ್ಳಿ. So first problem ಅಲ್ಲಿ solvent ಯಾರು ನೋಡ್ಕೋಬೇಕು. So volume ಅನ್ನು solvent ಕೊಟ್ಟಿದ್ದಾನೆ, pure solvent, ಅದಕ್ಕೆ solute ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ದಾನೆ, that is become a solution. Solution to boiling point rise ಆಗಿರುತ್ತೆ. So that is about 354.11 kV. So on MQ you have to calculate, kV is given. So in case ನಿಮಗೆ ಇಲ್ಲಿ TB T0P ಐಡೆಂಟಿಫೈ ಮಾಡಕ ಆಗಿಲ್ಲ ಅಂದ್ರೆ TB ಮತ್ತೆ T0P boiling point of solvent or boiling point of solution ಐಡೆಂಟಿಫೈ ಮಾಡಕ ಕನ್ಫ್ಯೂಷನ್ ಆಯ್ತು ಅಂದ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಯಾವ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೋ in the given value, ಎರಡು ಕೆಲ್ವಿನ್ ಟೆಂಪರೇಚರ್ ಯಾವ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಈಸ್ ದ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್. ಯಾಕೆಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಯಾವಾಗಲೂ ಸಾಲ್ವೆಂಟ್ ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So already we discussed in the elevation of boiling point, when the solute is added to the solvent, definitely the boiling point will be elevated. That's why the concept is called as elevation of boiling point of solvent. So ಇದು ಕಡಿಮೆ ವ್ಯಾಲ್ಯೂ ಇದೆ, ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಸೊ ಇಟ್ಸ್ ಶಾರ್ಟ್ ಕಟ್ ಅಷ್ಟೇ ಇದು ಐಡೆಂಟಿಫೈ ಮಾಡೋದಕ್ಕೆ. ಸೊ ಕಾನ್ಸೆಪ್ಟ್ ವೈಸ್ ಆದ್ರೆ ಈಸಿಯಾಗಿ ನಿಮಗೆ TB T0P ಗೊತ್ತಾಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಕನ್ಫ್ಯೂಷನ್ ಆದ್ರೆ, ಸೊ ಎಲಿವೇಶನ್ ಆಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳಿದಾಗ ಎರಡು ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ರೆ ಯಾವ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ ದಟ್ ಈಸ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್, ಯಾವುದು ಕಡಿಮೆ ಇರುತ್ತೋ ಅದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ಸಾಲ್ವೆಂಟ್ ಆಗಿರುತ್ತೆ. So this is a very simple to identify the boiling point of solution and boiling point of solvent, that is TB and T0P. And the substitute the values, there is a molar mass of solute 26.914 gram per mole. That's a 3 marks problem. So problems only, so formula ಗೆ 1 mark ಕೊಟ್ಟಿರ್ತಾರೆ, substitution, so and substitution 1 mark ಇರುತ್ತೆ, correct substitution ಗೆ correct answer with correct unit. So molar mass of solute, molar mass is always gram per mole. So that's about the question number 2. ಇನ್ನು ರಿಮೈನಿಂಗ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ, ಸೊ ಅದನ್ನ ನೀವು ನಾಳೆ ಟ್ರೈ ಮಾಡಿ. ಸೊ ಟ್ರೈ ಮಾಡಿ ಮತ್ತೆ ರಿಮೈನಿಂಗ್ 8 ಕ್ವೆಶ್ಚನ್ ನಾನು ಮಾಡ್ತೀನಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಸೊ ಮಚ್.